All right, so let me start with a statement which is older application or legacy applications are reliable, 100%. No doubt in that, right? But when it comes to the adaptation or automation, it becomes a little bit tricky with the legacy application. And it becomes really tough when you are new to that application. You do not understand the code base, and you want to modernize it, but you're still figuring it out how it works, right? So if I tell you that you can create an AI agent who will interact with that legacy system and can act and think on its own without rewriting anything, that would be pretty awesome, right? That will make our life a little bit easier as a developer or architect, something like that. So, well, to show you exactly how to do that, I am Dipali Thandre, along with my colleagues Franz Stefan and Jan Thuis. Together, we will demonstrate how to use Amazon Bedrock AgentCore to create that agentic AI into the existing legacy application. Okay, so before we dive in, I know you all are here to see us coding, troubleshooting online, everything like that. But give me a few minutes to go through the core concepts so that it is easy for all of us to follow what we are doing and why we are doing it. And after that, Franz is going to take over, and he's going to start by showing you how easy it is to create an AI agent using Strand SDK and run it on AgentCore runtime, all in an empty project. And after that, Jan is going to show you how to do the same thing within an existing legacy system. Okay, so let's start by understanding the agentic loop itself, or how the LLMs work on a very high level. So you begin with a prompt that you provide to the agent, and which could be something like, what's the weather in London today? This will basically trigger the initial loop. And agent, you can think it of as a controller or an orchestrator who knows what to do. Based on its logic, it will determine when and how to call a model. And model is the underlying intelligence. These are the foundation models which powers your agent and generate the responses based on the data that they were trained on. Next, we have, but sometimes model cannot answer you directly. For example, if I ask model, give me the 10 recent Jira tickets or Jira tickets for this project, model doesn't have the access to that kind of information. And that's why we have tools. And tools are the external entities that allows your agent to talk to outside world other than model to perform tasks like web searches, database lookups, code execution, calling APIs, anything that your agent wants to do for the task completion. In fact, the agent can create a new prompt internally that goes through the same loop again. And this is this process of acting, interpreting, planning is what we call as agentic loop, and it continues until the task or the ask is completed. The framework which we are going to use today to build the agent is Strand's SDK. And to define Strands, it is an open source Python SDK, which will let you build the AI agent with just few lines of code. What that means is, compared to other frameworks where developers are required to create the complex workflows for their agents, Strand's agent follows the model agnostic or model-driven approach, the similar thing which we saw in agentic loop. So what happens is Strands can run on any infrastructure, and it can call a model that are either hosted on Amazon Bedrock or even OpenAI model. So to quickly summarize this one, Strands will let you define how your agent can think and act on its own. But the next question is, how can you make this agent run in a scalable and production way grade? The answer is use AgentCore. So the AgentCore is a managed runtime and infrastructure offering from AWS, which will let you build, develop, and operate your AI agent at scale. It provides a lot of out-of-box components, which you can see, some of them you can see it on the screen. And if you're hearing about AgentCore or listening about the AgentCore for the first time, Do not worry about it. I will go on very high level about the components so that it is easy to follow. So we have an agent who can think and act, but it needs a runtime, which will basically allows to fulfill the business goals we have. For example, multiple users access, auto-scaling, sandboxing sessions, interacting with the tools which we will have in the agent, and most importantly, the performance. For everything like that, you will need an AgentCore. You can think of Strands as providing the intelligence to your agents, and AgentCore will provide the structure, the scalability, the security that your agent needs. On top of that, if I want my agent to remember the conversation I had in past, I could use memory in capability, which will store the context information across the session and the agents. Along with memory and the runtime, AgentCore does have built-in tool support. And in AWS, it provides the native integrations so that your agents can either store your data in S3 buckets or trigger a Lambda function or even write into DynamoDB databases. Other than native integrations, you can also register your APIs as MCP tools so that your agent can access them securely. So there is more you can see on top. It's gateways. AgentCore gateways will allow you to expose your internal APIs and Lambda functions, if you have any, as MCP tools. And finally, we have identity, which will give you plenty of options for authentication and authorization to basically lock down everything. So we have seen Strands, or you just heard me about Strands, which will define the agent capabilities, and you will run it on AgentCore runtime for the scalability it requires. So what is missing in these two? So the answer, before the answering it, let me ask you, how do you think that the context, the memory, or the tooling information, or any other thing is flowing reliably between the agent and the system it needs to interact with? That missing link is MCP. So MCP is the open standard which will let you define how your agents can connect or communicate with the applications and the services. It provides a consistent way to expose the capabilities. And what I mean is like your database queries or APIs or any other services as tools so that your agent can access them securely. Additionally, MCP doesn't just expose the capabilities as tool, but it also provides 3 key capabilities for your agent. And first off, that one is tools. And these are the actions that your agent can perform. Essentially, you're telling your agent, this is what you can do. For example, you can fetch the weather or trigger a workflow or even retrieve the customer data. Second, we have prompts. And these are the data, external data sources that your agent can access, like database, list, documents, files, URLs, basically all the information that your agent can read. And lastly, we have prompts, which is an instruction manual, including text and arguments. So it is basically telling the model that this is the given context for the response you will send. OK, so to conclude everything, once again, we have Strands that will let you define the agent capabilities. AgentCore will allow you to run in a scalable manner, and MCP will expose the capabilities as tools so that your agent can access them. Altogether, you will build an AI agent into the existing legacy application. So we have the scene now. We know we have gone through the concept. Now I'll ask my colleague, Franz, who will demonstrate to you how to create an agent using Strand SDK and run it on AgentCore runtime, all in an empty project. Over to you, Franz.
Thank you, Dipali. Let me switch over to the other screen. And hello, everyone. Franz is my name. So next to Jan, we will try to, for the remaining 15 minutes, to do some coding stuff. So as we started with the preparation for this code talk today, we had initially much more slides, but that's a code talk, so we are not here for going through a lot of concepts and theoretical aspects, but we had to set the scene to give an understanding that we want to use and to build an agent today with Strands, with the Strands Agents SDK, transform it to a Bedrock AgentCore agent, deployed then to the cloud, and then adding some capabilities. So we will start a little bit low level, but the level will increase. The second step, we had then to take a trade-off. Do we want to code everything from scratch? Would not fit within the time, so we will have some parts now that we want to go through. So we will also copy some code and then trying to give an understanding. Feel free to ask questions as well. We are here after the session as well in case of questions, but it's encouraged to ask questions in between. I hope you apologize if I sit down, but it makes it much more easier than to start with the coding. And to give an understanding what we want to start with first, I think you can see the screen. Just let me try to make this a little bit more readable.
Yeah.
That was my question.
Okay.
Is this good? Yes. So what we're going to start with, as you can see, or maybe not see, this will be primarily based on Python today. So we will use Python as this is the main supported language as of now to get started. There are other options how to use other languages. I will come to that in a second. But the first thing I want to go through is to make use of these three packages. So I have defined these three packages in my requirements txt file, and those packages are all we need to transform the agent that we're going to start now with to deploy it and also to AWS and then to extend it. So let me increase this here a bit. So in addition, what I'm going to do now is also to create a virtual environment. So next thing I'm going to do is to import the packages. And as these packages are getting imported, I need to create a file so that I'm able to, that's my main file for the agent itself. Reinvent demo agent MAM345, for instance. So what is now needed to start with a Strands agent? It's pretty easy and straightforward. First, what we want to do is to import the agent class from the Strands package. So as you can see, there is a class from the Strands package that is needed that we need to instantiate, which is receiving user input, process the input, and so on and so forth. So that's the first thing we need to start with when taking care of building our first agent or our initial agent. And then the remaining 3 lines to say that we have now built the first agent are those ones. So what we are going to do is now to instantiate the class. The second thing here is to take an input. So usually we are used to take an input from a user interface. We have also a user interface that I will show you in a second. But in that case, we are taking the user interface from the CLI. So in Python, that's input. Give my name and I give myself a name, and then passing the user input to the agent. That's pretty much it to get started. So if I'm going back to my CLI, just start it. And can now ask a question like, what is the capital of the USA? So based on that question, that's something the LLMs are trained on. So that's nothing very sophisticated, so we will get immediately a response. But if I would ask now something, as mentioned by my colleague Dipali before, that requires some real-time information, like what is the weather today in Las Vegas, I would expect that the LLM cannot return it back. And as you can see here, the LLM is not trained on real-time data, as we know. So this is something now where we need to introduce that what was mentioned by my colleague before, making use of tools. So these tools, either you can write as part of your agent itself, or you can use an SDK that has already some tools included. That's what we are going to do now. Or making use of MCP, which we will see then later on by getting some tools returned. So primarily when talking to agents, question is, what can you do for me? And I will get in response some tools that give you some understanding so that the loop between the agent and the LLM is about tools and the reasoning so that it can say, okay, I found a tool that might fit the prompt, I will make use of it. So this means we need to add something in addition, which is now the second package that we imported, we want to make use of, which is coming from the Strands tool package. So what I'm trying to import here is a tool that already exists as part of the Strands package. And you can see here a bunch of tools that we can make use of. We have here, we know that LLMs are not that great on doing mathematical stuff. We have a calculator tool. We have also an RSS tool. So we can use that tool imported. So to get back, give me the 10 most recent blog posts on the AWS channel in that category, for instance. HTTP request itself is more generic but very helpful because it has the capability to get outside to the internet, invoke some other APIs and give us something in return. And that's what we want to make use of. So something we need just to add on top of that is, or what I want to make use of, is a system prompt. System prompt primarily is like a persona. I want to set some guardrails or some pathways, so and maybe also some boundaries, so that it is easier to get further. So in that case, I'm asking and giving as prompt that it should only use APIs that are not requiring any kind of authentication, API keys, authorization, etc. Usually we want to do that for sake of simplicity. We are trying to get access to some external endpoints that are not requiring that. And the last remaining part that we need to take care of is to pass the system prompt to the agent. And in addition, we also need to pass the tool. In that case, we only make use of one tool. We can have more tools that we can make use of. In that case, we are passing the system prompt and the tool to our agent. So let's try it again if there is a change compared to the initial question that we have seen. So I'm again calling my agent. So what is the weather today in Las Vegas? And as you can see here already, it found a tool that it wants to make use of. I'm not debugging all information. We can take a look into that in a second. And what it tries now to do is to find some APIs with help of this agentic loop routing, and to go somewhere to find now the recent information about the weather. And it found something, as we got in return, something that seems very reliable and is a difference compared to what we have seen before. So we extended now our agent with tools. The next step is, as we have seen, we have three packages we want to make use of. So we use the first one as the base one for creating an agent, the tools agents package for making use of existing tools, and the third one is the Bedrock AgentCore package, so that we can transform this to a Bedrock AgentCore agent and being able to deploy it into the cloud. So what is needed there's not much needed to transform this one, but what a surprise, we need to import another class, which is coming from the Bedrock AgentCore package. So we need to we need to instantiate the class Bedrock AgentCore app, which we will do here. And by doing this, so what is it taking care of? If you're instantiating this one, it's creating an HTTP server listening on port 8080. And it has two endpoints that are important for a Bedrock AgentCore agent. There is a ping endpoint, so kind of a health endpoint, especially also interesting for multi-agent communication. And the most important one is the invocations endpoint, because the invocations endpoint is the one that is taking the prompt, listening to the input, so the JSON file in most cases, and then to proceed with the further stuff. We will see this in a second, how this is going to work. And in addition, some minor changes that we need to take care of. So we need to also have a decorator being part of the agent. This is mandatory for any AgentCore agent to have an entry point. So we have this decorator app entry point, and then a function that has the payload that we pass through. It's trying to find then in the JSON attribute for prompt. We are passing the user input, so it's primarily the same what we did here, but no longer from the CLI, but passing it then as a JSON, and then returning it back. And last remaining point we need to take care of is to add this here to make the app running. So that's pretty much it. Let's see how this is going to work. And the first thing you can see here, your agent is live and it's blinking. That's because now we have an HTTP server listening on port 8080 and waiting for requests coming from a client. So what I will do is to switch over to a second tab. And now I could use Postman or something that is integrated in the IDE, or I can use curl, which I'm going to make use of here. So I'm having here a curl command and trying to ask a question. So like, what is the weather today in New York? So this is getting passed to the running agent listening on port 8080. You can already see that it is trying to make use of the tool that is passed through. And here we are waiting for the response. This agentic loop introduced on the slides at the beginning, this iteration, this can take once, this can take multiple times. So what I've seen also were questions like, I am using Lambda, can I now use instead AgentCore? Probably in most cases not, depends on what the use case is, usually to transform something. But you should not forget this kind of loop might take a couple of seconds, especially in that case, as we are trying to find an API we are not aware of, because this is a decision taken by the LLM and the cycle between the agent and the LLM. In that case, you can see already that this took more than one iteration. You can see that there was at least a second invocation, but in return, we got then something that already makes sense. And this is the response that we got back from the client.
That's a question.
Feel free.
Can you get a streaming response from AgentCore?
Yes. Simple answer, yes.
In a minute. But good question. Great. So still, we're running locally. That's not what we want to do, but yeah, usually when we start developing, it's locally. So next step we're gonna want to achieve is how to deploy it then to the cloud. As mentioned before by my colleague, we have this serverless runtime, AgentCore runtime, where we can run our agents in, and the next step is now to deploy it. There are multiple ways how to achieve that. So you could use, for prod environment, you would use infrastructure as code, CloudFormation, Terraform, etc. Something that exists when making use, especially, or using Python, is a toolkit that I haven't introduced so far. So, because this becomes very handy as it gives you some some possibilities with help of the AgentCore CLI to deploy and to configure some stuff. When you're doing this with infrastructure as code, you need to pass some attributes and some configuration items, and this is then something we will see here in a second by making use of another package, and I'm trying to install this now. This is called, and this is not mentioned in the requirements TXT because I just want to make use of it in the IDE. Bedrock AgentCore Starter Toolkit, and as this is getting downloaded, I can now just say configure, AgentCore configure, and pass through my agent class. So it's now going to ask me some questions that are mandatory and important to mention, or you need to consider when you're using CloudFormation or Terraform. First question is, what should we name the agent? If you don't pass a name, it will take the file name. We are good with that, and taking this as standard. Do you have a requirements TXT file? Is it named requirements TXT? Yes, we are good. What kind of deployment configuration you want to make use of? So Bedrock AgentCore is GA for a couple of weeks, a few weeks. Started with container or Docker deployment. Now it's even more easier, very comparable to how you would deploy Lambdas. So you can use the first one, which is now the default one. It would then zip all the assets needed together, upload it to S3, and behind all the magic is going to get it deployed to runtime. Why you should then consider Docker as a second option, especially in that case if you have specific requirements, dependencies that you want to adjust in your Docker file. But also, one question might be, okay, Python is good, it's fully supported. What about Java, Go, or other languages? So you could theoretically make use of these other languages as well, as long they are not fully supported as Python in that case, by building then a wrapper so that you have these endpoints that are mandatory, the invocation endpoint and the ping endpoint. That's where you would probably then also make use of Docker. So we are good with the default option, which is the number one, which Python environment we want to make use of. And yeah, execution role, very comparable to Lambda. You have a role that has the necessary policies, actions needed to run the agent in your environment. If you don't have one, we are good to go with the default one, so it will take care of this as well. S3 bucket, where to upload it, I don't have one, I'm good to let one create it. Authorization configuration, so you can use OAuth, or in that case, I'm good with IAM authorization, take this one. You can also define some request headers, especially if you have multi-agent collaboration, very handy. We are good to ignore that as well. And last but not least, we have memory. Was mentioned in the slides at the beginning as well. If we are passing and having the communication in the user interface, we don't want to have, we have the context existing. We don't want to pass 50, 100 lines of information. We want to memorize it. That's where we have short-term and long-term memory that you can make use of here as well. We will come to that in a minute. I'm good to skip this, and that's primarily it. So what is happening now in addition is...
You have not skipped it yet.
I have not skipped it, yeah, sorry, thanks. Yeah. So, and one of the advantages is if you're using the starter toolkit, it gives you immediately also some best practices how to proceed. So AgentCore launch would be the command to deploy the agent, which would be now the next step. And in addition, what also happened is it's creating a YAML file locally based on what you have passed through, and for all further further communication with this starter toolkit, it will reference to this one. So I will skip this. What we want to do now is to invoke AgentCore launch, and it will show you now what is happening next. So it's packaging all assets needed, all imports that were considered in the requirements.txt file, and it's creating now the zip file, uploading it to S3, creating the execution role, and deploying it to the runtime. And to showcase you this in the console, it's going to look like this. Let me increase this a little bit. So you have this AgentCore service, which you want to start. You have then here some of these capabilities that we introduced at the beginning. And let's start with runtime. And you can then see here immediately all the agents that you have deployed and running in your account in your region. So in that case, I'm in US East 1, North Virginia, and I have here already my running agent. So if I'm switching back, I also have here a response in a positive way. You will get also here immediately a possibility to tail on your CloudWatch logs. So in case something happens, observability is a very important aspect also of AgentCore. So open telemetry is fully supported. We have all the traces and spawns that we might see also in a second. And now we can invoke this from the CLI, or let me switch now to introduce you to a user interface. Which more or less is listening all the agents that you have deployed in your account, and that's the one that we have deployed a minute ago. And I can now ask more or less the same questions as we have done before. What is the capital of, let's take something different, Germany. And the initial invocation of the agent may take 1 or 2 seconds longer as it's starting to spawn up, but will then remain in the session. And you can see in a very dirty way, just the JSON output, it's getting us something back from the LLM. I can do now the same with something we have now seen 3 times. So to not bother you with something we have already seen, I'm happy to switch over to my colleague Jan, who will try to make use of the existing agent and extend it with more capabilities, and also to attach it to the legacy app without touching the legacy app.
Yeah, go ahead.
Sure.
Before you deployed the application to the cloud in the second iteration, why did it take the agent twice to get the demo?
You can debug the whole cycle and what is going. So the whole communication and the cycle between agent and the LLM, you can for sure trace this. For sake of simplicity, I have skipped this now. But you would then see it could be because it did not found the API, or it found an API that was not able to respond in a given time. You will get all this information out as part of your debug information. In that case, it was not disclosed in this demo, but usually there are reasons why API is taking too much time. It's not responding. I'm not getting it in the expected manner. Everything is disclosed in the output as you define in your debug configuration. But fair question, especially for HTTP requests, this may take longer because it's kind of a black box where it goes. If you then use something that you have more control over, which you will see now in a second, it's much faster because we have the expectation on the endpoints we want to take care of. Jan will introduce you to that.
Yeah. Also, to add on this one, adding a general tool like HTTP request means the LLM is like tempted to use it for everything, right? It might know what the capital of Germany is, but it might ask an HTTP endpoint nonetheless to validate it's really true. So these general tools might tempt the LLM to do stuff which we don't want to do. Okay, looking at your faces, you want to see some legacy applications, right? You are missing it already. So we do have a legacy application, and I have no idea what it is doing. Of course I have, but let's assume we just got this on the table and we have to add some agentic AI stuff to it. Okay, so it's running on ECS, it's some Java application, it's using some database. Let's check it out, what it is doing. And I heard you all love unicorns, so the great part is it's a unicorn store, and we can shop unicorns. That's great. So let's go ahead and add an agentic capability for our users to not only use this website, which is, well, quite old, but also use an agent to shop unicorns, okay? For this, we have the first issue here. I don't know the endpoints the application provides. I have no idea which REST endpoints are available. So my first idea would be, let's use Amazon Q Developer and ask it to create an open API specification out of my application, right? That's quite simple. I don't know what's going on inside the application, but let's use Q Developer to figure it out. So please create an open API spec out of my legacy application. Please ignore text plain endpoints because we don't want these. Okay, so while Q Developer is now working, I will show you the result in a second, but I prepared the result already, and I will pick this up to use. So we do have an open API spec, and I swear this has been generated by Q Developer. We will just pick this open API spec, and we will go and switch over into the AgentCore console into the gateway. So the gateway has been introduced. It's a way to host tools, basically. And we have provisioned one gateway already, and you can add several targets to a gateway. Targets can be, and we will see that in a second, targets can be MCP servers, right? So which you find on any open source, GitHub, for example. It can be a Lambda function, and it can be REST APIs. So we can go ahead and say REST API, open API schema, and inline schema. That's great. We are just pasting the whole API schema that has been generated by Q Developer in here. For authorization, we are selecting an API key, which we don't need. Our application is accessible from the public internet, but in case you could also configure OAuth or an API key. I will add this as a target to my gateway. That's great. So now we have a second target. We will get to the Lambda target later on, but now this gateway is able to interact with our application using the open API schema. So what we have to do next is we have to update our agent to make use of this gateway, right? That's the next step. To show you what we are going to do, I will quickly switch over to this architecture. You can see the legacy application part, right? And we are going to add the gateway. We are going to use our agent on the left side. We are using the front end that you have seen already. And yeah, we will, the goal is that our client, our agent is using the gateway and then the open API specification to invoke endpoints in our legacy application. So we are not touching the legacy application in any way. We are really enhancing it.
Just to add a sentence, because I had recently a conversation with a customer who had the same challenge. They have a legacy application. There is an open API schema that you can write or exist or generate with AI. And the question was, yeah, okay, but where do I need to write the code? You don't need to write the code. The translation, that's where the gateway comes in and makes it so super easy, is the open API schema that translates then all the paths into tools that you can run and invoke from your agents. So you don't need to touch your legacy app, you don't need to write a code. You're writing a code to connect to the gateway, which has multiple targets, but you can communicate without making any changes, writing any code to make use of your legacy application.
Okay. Then we are going back to the IDE. I have great news. QDeveloper was able to create this Open API specification file. I will show you. So he was able to create it. We could have used it, but I wanted to speed up things, right? So what we are going to do now is we have to enhance our agent. Like Franz said, we have to add the capability for the agent to invoke the gateway, which means fetching some credentials and configuring the gateway. I will guide you through it. I will copy stuff over to make it more quick, but we will get there. So the first thing we have to do is...
Can you increase the size a bit? The size to increase it in general?
Yeah, I will increase it. Sure.
Thanks.
So what we are going to do is we are adding some more imports at this point. I will guide you through it. I'm setting up the logging because I want to be able to see what the agent is doing. And as I mentioned, we do have to get some parameters or some secrets, right? We have to authenticate towards the gateway, and we also have to get the gateway URL. So what I'm doing here is I'm defining some variables, which is the gateway URL. So this is the address where our gateway is reachable. I'm defining the memory. We will get there later on. And I'm also defining the AgentCore gateway OAuth provider URL. This is used to get an access token, right? So the agent is calling the auth provider, getting an access token, and with this access token, he is allowed to access the gateway. I'm defining a model ID as well and a system prompt, which is a bit different, saying you are an agent which is helping with shopping unicorns. So that's it for now. We are getting the parameters. Next step, what we have to do is we have to get this access token. And the great thing is in the Strand SDK, there's a decorator requires access token. We are just passing in the OAuth provider URL, and we are getting back an access token. That's quite nice. Now we have to change the agent initialization a little bit. When we are talking about tool usage and gateway usage, we have to take care of several user sessions, right? So users do have sessions with an agent, and we have to handle that internally to make sure that a tool is bound to the session context of a user. For this, we will just add the init agent method. And yes, that's a bigger one, but I will guide you through it, what it is doing. So in this init agent, we are trying to get the agent from the context. All the context stuff that you are seeing here is completely related to session management. So it's all about separating user sessions and getting an agent for this user session. If we already have an agent, that's great. We just return it because it has been initialized for this user session already. If not, we want to initialize it. Get the gateway access token, right? As I mentioned, you need to authenticate towards the AgentCore gateway. We are doing this using the method we just created, which is getting the access token. Then some sanity checks, that's fine. And the next step is we are creating an MCP client. So our agent will now use MCP to communicate with the gateway. And the MCP client takes our gateway URL and the gateway access token. And we are doing some timeout, right? So 2 minutes timeout for a call. That's fine for our demo. So afterwards, we do have the gateway client. We have to start it, right? We are starting it, and then we save it in the session. That's happening here. So for the next request the user does, the session is already started, and we will just pick up the existing agent, including the sessions. We are creating the model. We are selecting a specific model in this case. And then we are initializing the agent like we did before. We are passing in the model, and we are passing in the gateway tools. And I was jumping over this one. This is quite important. After initializing the MCP client, we have to fetch the tools which are available, right? Our agent is running in one time, and the gateway is running somewhere else. And the agent has to fetch the available tools from the gateway. to inject it into the prompt, right, for the LLM to be able to make a decision. And that's what's happening here. So on the gateway client, we are invoking the list tools sync method, and we are retrieving all the tools, meaning targets, and for the OpenAPI specification target, all the methods available. So we are getting back the tools. We are passing this to the agent, storing the agent in the context so we don't have to do it again in the next session. And we are nearly done. Just a small step left, which is the lifespan manager. So you can see that we have been using the Bedrock AgentCore app before, but now we are passing in the lifespan. That's also completely related to session management. I will not go too deeply into it, but basically it's tying the agent and the gateway client towards this session, and Bedrock AgentCore, the SDK extension, is taking care of this. Great. Then we are nearly done. I just want to make it a little bit more beautiful, and there was a question about streaming. We are doing that now. So the agent invocation, let me go over. There we go. So as you have seen in the user interface, we were returning the JSON, right? And that was not really user-friendly. If we want to offer an end-user experience for shopping unicorns, we have to do some parsing. So I'm invoking the agent async here, and I'm then parsing the results and just returning the real text. Also, the other things, I'm just doing some sanity checks to check if we do have a session ID, if we do have a user message, so a prompt coming in, and then I'm initializing the agent and invoking it. That's all what we had to change. And this is a one-time change that you have to do. Now it's as easy, like Franz mentioned, it's as easy as adding a second target to the gateway, and the agent will automatically pick it up. So let's see how that works by updating our agent. I will just do an AgentCore launch, like we have seen before. I've configured this stuff, so I have a YAML file here, and we will now update the agent and see if we can get some information out of our legacy application. So
You want to switch to the console?
I mean, yeah, we can quickly go to the console and take a look. So we do have a one-time here. This is the session name agent, and it has been last updated at 12:18. Yeah, that's exactly what happened. So let's switch over to the browser and take a look into our front end. I will just reload this one. And we are creating a shopping session. So these are the sessions. Shopping session is the session ID that's getting passed to the agent one time, and based on the session ID, it will initialize an agent. Okay, which unicorns do we have in store? Let's see. So the first request, as Franz mentioned, the one time has to spin up, and the agent is being initialized, including fetching the access token, fetching the tools from the gateway. So the first request is taking some time, but afterwards, the requests are quite fast. Okay, that's quite nice. So we get an answer that we have 3 types of magical unicorn products: a unicorn float, a unicorn party dress, and a unicorn hip hop. That's great. So based on the OpenAPI spec, the agent was now able to figure out the user's intention and giving me the products. And I would like to shop a unicorn. So I would like to go ahead and say, let's buy a party dress, for example. But for this to work, we have to create a user account, and the agent has to remember which unicorn I want to shop. So we will make use of the memory now, because memory allows the agent to retrieve previous messages that I have sent and that he answered. And I promise, compared to what we did before, it's a really small change. So let me quickly switch over. The memory one is really quite easy. So we are going back into the IDE. There we go. And when we are initializing the agent right here, we are just adding the AgentCore memory configuration. So we are passing in the session ID. I've shown you in the user interface, we can create a new session. And of course, we want the memory to be separated between sessions, right? I don't want user A to retrieve information from user B. So, and we could add the actor ID. Not doing that today, but we will separate on the session ID. And next step is, now that we have the AgentCore memory config, we are creating a session manager, right? And in this case, it's an AgentCore memory session manager. And we are just passing this one over to the agent. So that's the whole thing. The memory has been created by me before, but as you have seen in the CLI, which Franz used, you could use this CLI to create a memory for you. So that's quite convenient. Okay, change to the agent has been done. Next step, we have to update the agent. And, oh, that's local, AgentCore launch. So it will now just update the agent, and afterwards we are going to shop a unicorn. Let's go back to the console to check what's happening. I can quickly show you the memory that has been provisioned here. So as you can see, we do have a memory available. We can also see that events expire after 30 days, so nothing super interesting here. But
Not to forget about observability, to showcase this as well.
yeah, we can take a look at observability in a second. I quickly want to buy one unicorn at least. The agent has been updated. We will go back to our front end and create a new session, which is the memory shopping session. Okay. I want to buy a unicorn. Now, I want to show the guided experience that the agent will provide. So, I mean, I was quite unspecific in my intention, quite unspecific. I expect the agent to deliver the available unicorns to me, and then he will guide me through account creation and stuff. Yeah, that's great. So he's offering me the available unicorns. I'm for a party dress, definitely. Let's go with the party dress. Okay. The next question should be, do you have an account, or would you like me to create one? Okay, I want to create an account. It needs my name, first name, last name, and my email address, which is this 345 Monday at Amazon. Okay, let's see. He should figure out all the details. And in the background, now this loop will take some time because he will create an account and he will add the unicorn to my basket in this account. And this legacy application has no checkout process to it, but we will log into the application and see that it really worked, right? So account has been created and I do have a unicorn party dress inside my basket. That sounds fantastic. Let's go to the store. I'm going to log in. The password is not being checked, so I'm just using anything in this case. But we can see I'm logging in, and I do have one item in my cart. So by just adding an open API spec to the gateway, the agent is now really able to interact with my application, which I have not touched in any way for this example.
You could maybe show in the open API the post method that was used for that case.
Yeah, I would like to show you some observability parts for the last 1 or 2 seconds, because adding all these capabilities to the agent, it might get quite hard to understand what is happening, right? And for this, we can enable tracing on the agent runtime, on the memory, on the gateway. And what this allows us to see is a whole overview of what is going on. So we can have application map. So if we go into the application map and expand that, we can see our agent right here. That's the agent running on AgentCore runtime. We can see that it is using the Bedrock AgentCore service, of course. We can see that it is using our gateway. We can see that it's using the memory and the OAuth, right? We are getting an access token. We can also see that it is invoking Bedrock and the LLM, really, and did 8 requests to the LLM. And we can also see that we are using Secrets Manager to fetch the OAuth secret and the gateway URL. So we get a real insight into what's happening. And the real cool thing is the gateway is invoking our unknown remote service. So we can see that the gateway is invoking our application, and we do see that several requests happen to this one. And I think that's a great way to really see what the agent is doing and also how many requests to an LLM it's doing in a great visual way.
To wrap this up, these 3 QR codes, especially the third one, all those demos that exist, especially the third one, is a large GitHub repository with a lot of the tutorials. The second one with a lot of use cases. So they're ready to deploy CloudFormation templates that are primarily showcasing that what we tried to do now in 60 minutes. We had some stretch tasks that we wanted to show you today as well, but with respect to the time, not feasible and easy. But really encourage you to make use of the GitHub repo. Deepali, you want to wrap up with the last one?
No, I think you did it. I hope you guys enjoyed our code walkthrough. Hopefully you're taking something back home to try that out in your personal environments or company's environment. Enjoy the rest of your day. Thank you for attending, and please provide your feedback if you loved our session. Thank you.
In the mobile app. Thanks.
Thank you.